Let's take a look at an example of how easy it is to use Solidworks Simulation, or FEA, to zero in on the best design to move forward with. In this example, we have a mounting bracket where we have two different concepts. One has a single web design, and then we have a double web design. We want to determine which one of these is a better choice for our needs. Simulation is about testing designs on the computer, so the first step is to pick the type of test that we want to do. You can see we have a lot of choices. We're just going to focus on static strength. For this, it is just a matter of applying a load and holding the part in place as we would for the real experiment. In this case, we're going to apply a fixture. There are several ways we can go about doing this. We could hold our part just at the bolt holes, or, as in this instance, so that the back face is welded onto the wall. With the load, we can conveniently use geometry to specify the location as well as the direction. We're going to apply a 20 kilogram or 200 Newton load on the bracket, and that's really all there is to testing our part. We also have symbol displays to provide visual feedback on how our test is set up. We select Run, and it meshes the part and then goes through the calculations. We can use the Command Manager to interact with the model, but the right-click menus are more convenient once you're familiar with the steps. So you can see with the double web design that we have a stress of just over 11 megapascals in the web. Well, what about the other concept? If we change to the single web concept, we can take advantage of the simulation study we just created and make a copy using the duplicate command for this configuration. We need only click on Run to get the results. It will automatically mesh the model and get our result in a couple of seconds. We can see that for the same applied load, we have a peak stress of only 8.5 megapascals, down from 11, so about a 20% reduction. So this would suggest the single web design would be a better option for this load condition. Now, if we're more concerned about the stress near where we are mounting this onto the wall, we can refine our restraints. In this case, instead of assuming the entire face is welded, we can assume that it is bolted to the wall and that the bolts are taking the entire load. This is going to be very conservative, but it's worth checking it out. When we say conservative, that means the stresses will be higher than in reality. So instead of picking the back face for the fixture, we select the bolt holes. And when we run the simulation now, we will see what the difference in stress is. So we were around 8.5 megapascals, and now the peak stresses are significantly higher and localized around the bolt holes. For the real bracket, the stress result will be somewhere between these two solutions. And we can actually account for that in Solidworks Simulation if desired by creating bolts. So it's easy to do some quick design concept evaluations in Solidworks Simulation and choose the best design to move forward with. Solidworks applications provide great capabilities you can use right away for design, simulation, communication, and file management to work faster and make your products better. Explore all the features in the demo library or contact your nearest Solidworks reseller.